A very good evening to one and all gathered here. I am Sweeti Kumari from the Department of Electronics and Communication Engineering, here to host today's workshop on a simulated world organized by St. Joseph's Robo Club, St. Joseph's Institute of Technology. It's my great pleasure to extend a cheerful welcome to you all here. On this beautiful evening, I would like to take this opportunity to extend my first and foremost gratitude to our Honorable Chairman, Dr. B. Babu Manoharan sir, our Managing Director, Mrs. S. Jessie Priya ma'am, our Director, Mr. B. Sashishekar sir, and our beloved Principal, Dr. P. Ravichandran sir, for giving this opportunity. I would also like to take this opportunity to thank our Head of Department, Dr. Sinyana Kausalya ma'am, Staff and Student Affairs, and Dr. G. Rohini ma'am, Lab Affairs, for their endless support. I would also like to welcome the Head of Department and the Lab HODs of the CSC, IT, EEE, Civil, Mechanical Departments, and Department of Science. Last but not least, I would like to welcome the students gathered here for this session. It gives me an immense joy to welcome you all to make this event a grand success. It's my pleasure to welcome Ms. R. Madhumita and Ms. B. Reshma, the wonderful speakers of today's session. Now, I would like to share a few words about the speakers. Our first speaker is Ms. R. Madhumita. She is a student of second year EC department and she is a member of IEEE EMBA Society. She is also part of the design team in the Electronics and Robotics Club and won mini project expo conducted by the Robotic Club. She has done many projects like line follower robot, obstacle avoider robot, and computer controlled robot. She has also conducted a webinar on animatronics and a student development program on Pygame development. She has also created a language translator app using Flutter. Before we start the session, I would like to tell few instructions to be followed by the participants. Kindly post your queries and questions in the chat box and they will be discussed with the speaker at the end of the session. The feedback link will be posted at the end of today's program. Now, I invite our first speaker of the day, Ms. R. Madhumita, to kindly start the session.
Thank you, Sweetie. Good evening, everyone.
Madhu, can you share your screen?
And stuck ಆಯ್ತು. No, the screen stuck.
Okay, you take your time, Madhu.
Screen stuck. Move. Screen stuck ಆಯ್ತು.
Okay, Madhu. Don't get it.
Tell the screen stuck. Reshma, when ஆரம்பிக்க சொல்லு.
Okay. Reshma?
Jamuna call பண்ணி Reshma ஆரம்பிக்க சொல்லு. Or put it in the group.
Okay, now start பண்ணட்டா?
Yes, Reshma, yeah.
Yes.
Okay,
yes, Reshma, please start.
1 minute. Yeah, I hope you guys are able to see my screen.
Yes, Reshma, it is visible.
Okay, ma'am. Now, good evening to one and all present here. I'm Reshma B of ECE department, and I'm here to teach you about how to construct an automatic street light using Tinkercad from scratch. Now, this is a very simple circuit. The aim of this is to create an automatic street light with the help of a photoresistor. Now, like I said earlier, it's a very simple circuit. All you need is like a couple of resistors, connecting wires, breadboard, 9-volt battery, photoresistor, LED, and an NPN transistor. Now, let's see all these components in details. Now, first, we'll see about photoresistor. It is also called as a light-dependent resistor, and the reason why it is called so is that when a photoresistor comes in contact with light, its resistance decreases, while if there is any zero amount of light surrounding it, that is, if it's in complete darkness, its resistance increases as high as several mega ohms. Next up, we're going to see about the light emitting diode or the LED. This is going to be a main source of light. Now this, over here you can see like two legs, the anode and the cathode. The anode is like the longer and much more bent leg, while the cathode is the shorter end. And finally, we will see about the bipolar junction transistor, also known as the BJT. As you guys know, it is a semiconductor and it has two configurations, namely NPN and PNP. For our circuit, we'll be using the NPN transistor. Now, the reason why we're using NPN transistor in our circuit is that we all are aware that transistors are used as switching devices. And since we need a switch to like turn on and off a circuit automatically, we are using a bipolar junction transistor. Now, without any further ado, let's just move on to our circuit. Now, I here have created a blank project. Here is our blank project. Now, first let us assemble our components. I'm bringing in my breadboard first and assembling it. Next up, I'm going to bring in my LED. This all is like available in like the basic component section, so you don't have to like search for them. Now the LED is available in like different colors, and the colors which Tinkercad gives you are red, green, yellow, orange, blue, and white. Now it depends on the color. The voltage of the LED also like varies. Now since we're using a red colored LED, the voltage of this would be 2 volts. Next up, I'm going to bring in 2 resistors. I'll alter the value like later. Next up, I'm going to bring in my photoresistor. And I'm going to place it over here in my breadboard. And finally, I'm going to bring in my 9-volt battery, which happens to be our source of power. There it is, sorry. Now, for my convenience, I'm going to rotate it so that the circuit will be much more visible. Now I'm going to alter the value of my resistors. I'm going to keep the first one as 220 kilo ohms and my second one as 330 ohms. And finally, let me bring in my NPN transistor. And I'm going to place it exactly over here. Now you can see this end is the collector end. Here we have a base in the middle, and at the last is the emitter. 1 minute. Sorry for the interruption, guys. It's just sorry. Yeah, once again, sorry for the interruption, you guys. I'm gonna place my photoresistor over here. Now, at one end of the photoresistor, I'm gonna connect my 220 kilo ohm resistor, and I'm gonna rotate it accordingly so that it's in series connection for me. There you go. And this one, I'm going to connect it to the other end of my 220 ohm resistor. I'm going to rotate it again. So with that, we've assembled all of our major components. Now it's the only part that's left is the wiring. Now I'm going to connect the positive part right over here in my breadboard. And I'm going to connect the negative part. I'm going to ground it right over here. Now Tinkercad gives you the option to change the color of the wires, so I'm going to change it accordingly. This one I'm going to give it as red, and this one I'm going to give it as black to signify between positive and negative. Next up, we have a LED. We're going to connect the LED to our breadboard. As I've said before, the bent end is the anode, and I'm here, the shorter end is the cathode. Now I'm going to connect the cathode. I'm going to loop it up just to make my connection more neater. And I'm going to bring it over to this line. And now I'm going to connect the anode over to the free end of my 330 ohm resistor. And I will be changing the color of this to red. Now next up, we need to connect our transistors. Now the base, I'm going to connect the base over to, okay, I'm going to bring this up. Over here. Let me bring it a bit lower. I've connected my collector end to like the free end of my 330 ohm resistor. Next up, I'm going to connect this one end of my photoresistor to the base. And finally, I'm going to connect the other free end of my photoresistor to the emitter. Right over here. Let me change the color of the wires. Now there's one more thing left to do, that is grounding my emitter. So I'm going to connect this to the ground and I'll be changing it to black. So with that, our connections are over and I'm going to start simulating my circuit. Okay, clearly I've gone somewhere wrong over here. You see? So let me just try connecting it from the beginning. I don't know where I went wrong. Please bear with me, you guys. I'm sorry for this mishap. So I connected one end of my 220 ohm resistor to the photoresistor, and I'll connect this right here. I'm gonna move my transistor away. Next, I'm gonna connect my cathode. Once again, this should be working. I don't know where I went wrong. Okay, we've connected the anode. Next up, cathode, sorry. Then I'm going to connect the anode over to the free end of my 330 ohm resistor, and I'll change the color to red. Then I'm going to ground my emitter. Now we're done with that. Next up, we need to connect the photoresistor. Connecting this to the collector, and then connecting one end of my photoresistor to the base, and the other end to the emitter. So I'm going to start simulating. It should be working.
Ma'am,
Okay, the connections are right, but I don't know where it exactly went wrong. Okay. Okay, it's working now, thankfully. Now, when I clicked on start simulation, you can see that the LED started to glow. The reason why is that there is no light incident on the photoresistor. But if I give it more light, you can see that the LED gradually stops glowing. The resistance of the photoresistor decreases. While if I get rid of any sort of light and make sure it's not incident on the photoresistor, you can see that the LED turns back on. So with that, we've completed the entire setup of our automatic street light. To sum it all up, we first brought in a 9-volt battery, and then we brought all of our components in, our LED, our NPN transistor, our two resistors of 220 kilo ohms and 330 ohms respectively, and our resistors, and finally our breadboard. Then next what we did was we managed to give all of the connections, and the reason to make sure it's like all neat and all, and finally we got the output and we make sure that the LED lights up. So this is all it's required for an automatic street light. Now I do have a few problem statements and I will put them forward in front of you. Now you've seen that how we managed to create an automatic street light using photoresistor. But what else can we do though? Is it like the only thing we can like apply our photoresistors in? Absolutely not. Because we have like a whole lot of applications to do them, and I would like you guys to try them all out. The first one is automatic solar tracker using LDR and Arduino board. Now, all it takes for you guys with the circuit is an LDR and an Arduino Uno board, which my friend Madhumita will be explaining later. Next one is a security alarm system. You can build them using LDRs as well. And finally, using the same principle which we implemented in our street light, you can build a light detector too with simple transistors and a potentiometer. So with that, I would like to conclude my session and hand it over to our next speaker, our Madhumita. Thank you so much, you guys, for being patient for so long, and thank you for listening. Thank you.
Thank you, Reshma, for sharing your knowledge. Sorry for the inconvenience, and here is the introduction for Ms. B. Reshma. She is an alumni of SCAD Hart Matriculation Higher Secondary School, and she is currently pursuing BE in Electronics and Communication Engineering. She is a member of IEEE EMBA Society and the Electronics and Robotics Club. She has also completed Movers, Flyers, and PET conducted by YLE British Council. She has conducted a webinar on virtual reality and a student development program on Pygame development. She has also created a language translator app using Flitter. Now, I invite Ms. or Madhumita to kindly continue with the session.
Thank you, and I'm really sorry for the mishappening that happened before. I'm extremely sorry once again. So let me start with what is the intruder alarm. Intruder alarm is basically an electronic device that tells us beforehand when anything else is happening. Once again, I'm not sure if my tab is being presented to you guys. Yes, so I believe you can see mine now. Okay, so I would like to thank Sweetie before the intruder. So it's an electronic device that emits a loud noise when someone attempts to gain an unauthorized entry to a building. So this is what I found when I looked into the internet. So how would it be if we can create our own intruder alarm for our own houses? So that's what we're going to be seeing in today's session. So before going to that, I would like to show you guys a sample or how it goes. Let me quickly run down the components we'll be needing. We'll be needing 5 important components for this presentation. So the main component is the Arduino board. It has 14 digital pins starting from 0 to 13, and then 5 analog pins starting from 0 to 5 here. And then we have 2 ground pins and the 5-volt pin and the 3.3-volt pin and the input pin here. So this is the reset switch pin. So this pin indicates whether when the Arduino board works or not. And this on button LED here tells us when the Arduino board is on or not again. So this USB port here allows us to connect the program to load the program into the Arduino Uno board. Like I said, there are many types of Arduino boards available. We have the Arduino Uno, mega, nano, mini, etc. It is basically a microprocessor, and this is a microcontroller present here. So this board helps us to supply the input, and it converts the output necessary for us. And this is the charging port here. So this is the LED here. So as you all know, it's a light emitting diode. So it's an output device that helps us visualize the output that we need. Lows when we get a high, that is, and when the output is 0, that is low, the LED doesn't glow. So with this, we can easily understand what we need to know. Need is a resistor. So all of you might be a bit confused with how to learn the readings of the resistor. So this is a simple chart here, and the last ring is the gold or the silver ring that usually tells a tolerance. The first 3 rings tells us the value of the resistor. The first 2 rings is the number value, and the last ring is the multiplier value. So the first 2 rings is basically green here, and the other is the blue one here. So the value is 56 into the last ring, that is orange ring, tells the value of the multiplier into 10 to the power 3. So suppose in the place of green here, I have yellow, and in the place of blue, I have violet. The value will be 47 into 10 to the power 3 for this. Now moving on to the fourth component, we have the buzzer. The buzzer is again a passive device here. So the buzzer is basically used to emit the sound that we need for the alarm. So buzzers are basically used for emergency cases, for fire alarms, intruder alarms, etc. So the piezo buzzer is special because it has a piezo crystal inside the buzzer, which melts when electricity flows through it. Sound. So the last final component is the PIR sensor. So this is the downside of the sensor, and this is the upper side of the sensor. So there are 3 pins here, one for the power, the signal, and the ground. So main difference, we can use multiple sensors for our intruder alarm. One main difference between using the PIR sensor and the IR sensor is that the PIR sensor not only detects the object in front of us, but also the movement made by the object in front of us. So that makes us more advantageous here. Now let me show how to start doing this intruder alarm. So I'll be doing this intruder alarm on Tinkercad. So once you can create your own account on Tinkercad, you can create multiple projects here. So now that we're on lockdown, we can't go by components right now. So we're using Tinkercad here, which helps us simulate whatever we need to try here. So the main thing I'm going to be using here is Arduino board. So let me place the component here. Just a second, guys. Yes. So let me show the parts again quickly here. So let me zoom in. Okay. So we have again the 14 digital pins and the analog pin right here. And the 6 analog pins here. We won't be using the analog pin for the intruder alarm, and we only be using the digital pins. Okay. So let's place the next component, which is going to be the resistor. So you can place a resistor in any one of the digital pins you can use. But since I'll be needing the ground, I am going to place a resistor in pin number 13, so it's closer. The next component I'll be needing is an LED. So let me place the LED here. So now what we do is we connect the LED to the we connect the anode of the LED to the one end of the resistor. Yes. Yes. Okay. So this is the nano. Okay. Is my screen still?
Madhu, can you share your screen?
Yes, ma'am. Yes, ma'am. Just a second, ma'am. You can see it now. So, okay. So, I'm so sorry again, guys. Let me start it from the beginning. Okay. We got the Arduino board here. So, we place the Arduino board. And let me zoom it once to show you. We have the 14 digital pins here again and the ground pin. And we have the 6 analog pins here. Okay, so now moving on to the next component. So we'll be using the LED now. So I place the LED kind of in between the ground pin and the 13th pin. So you can actually place the LED anywhere you want, but since it's more closer and to make the circuit appear more neat, I'm going to place it here. So the next component we need is a resistor. So like I said again, we can place the resistor anywhere we want. And anywhere we want in one of the digital pins. But since it's closer to the ground pin, I'm going to be placing it there. Now we connect the anode of the LED to one end of the resistor and the cathode of the LED to the ground. Now the next component we'll be needing is a piezo buzzer. Yes, so let me take the buzzer and keep it here. Okay, so now this buzzer again has a positive and the negative end. The positive end goes to the same digital pin where we placed our resistor and the LED, and the negative pin goes again to the ground. So here we go. Now let me place the last and final component, that is going to be the PIR sensor. Okay. So like I said before, the PIR sensor has the signal, the power, and the ground here. So I take the signal here. Stuck again. I'm so sorry for this, guys. Like, I'm having a bit of trouble. Got it. Yes. So we have the signal pin here. So I connect the signal to any one of the digital pins I want here, other than pin number 13. So let me go for pin number 2. I'm connecting the signal pin to pin number 2 here. And now the power to 5-volt pin and the ground pin to the ground here again. So we can actually change them for identifying it. So, right, and black for the ground, and here black for the ground again. And So now that we differentiated the ground pin and the input pin, now let's go on to the code. So before start typing the code, many of you might be wary of the code. Like some people wouldn't like the code usually. So Thingified has an absolutely brilliant option for us. They help us build the code using blocks. So at least the input part, the output part, and the mathematical control part. So that's how we're going to build the code here again. So let me first take the input. So now that we get the input, so let me first take the output statement and place it here. So now that we have the output, we need to get an input for every output. So the input is, since we're only using digital pins here, I'm going to be using digital pin. Read digital pin. So there we go. Now we need to know which pin to select. Since I've connected pin number 2 to the signal, that's the pin I'm going to be requiring here for the program to read. So let me select pin number 2. So now I have the input and the output statement. So I need a condition now. So for that, let me go to control statements and let me pick the if-else statement. So we see this empty box here. So that box stands for the mathematical controls and variables. That is the if condition. So the if condition here is less. So I'll be needing equal to 1, because like I said before, the LED glows if it's 1 and it doesn't glow if it's 0. So here we need to include the input here. So input again, read digital pin. Which digital pin to read again? So I need to read pin number 2. So pin number 2 equal to 1. So if pin number 2 equal to 1, what will happen? So I'll go to the output and set pin and place 1 here. Set pin 13. So pin number 13 is going to be the output pin here. So pin number 2 is the input pin and pin number 13 is the output pin. So pin number 13 is what which make the buzzer to make the noise. So set pin 13 to high. And now again set pin 13 to, so when we have if to high, then the else has to be low. So selecting pin number 13 to low. That's it. That's the program code for this. So now let's start simulating. Let me push this code here and let me press this button. So I hope you can see the colored part here. So that part is the range with which the PIR sensor can detect any object or movement. So I hope you heard the sound now. So that sound was made to alert anyone. So now I move this here outside the range and I can't hear any sound. But the minute I take it close, I hear the sound again. So let me show this again in the serial monitor. So let me move this side a bit. And I'll show you the serial monitor code. Okay, the serial monitor actually shows if when we hear the buzzing noise, that you should have seen the LED glow, and that would show. So I'll start the simulation here again. Start simulation. I press on the PIR sensor, and yeah, so you have seen the LED glow here, and we see ones. Now when I take it here, we only see 0. But the minute I take it here, we see 1. So I hope you saw the ones there. So let me stop the simulation now. And let me explain the code part here. So now you saw the blocks. So let me just show it in a C program. Yes. So we have the C++ program here. And this program, it just has 2 parts, the void setup part and the loop part. So in the void setup part, we only do 2 things, get the input and show the output. And then the void loop part is where the condition is done, where the condition checks if the LED glows or not. So we have pin mode 2, input. So like I said before, the digital pin 2 is the input, and the digital pin 13 is going to be the output. Now many of you people wondering why is serial dot begin 9600. So this 9600 is the baud rate. So it tells how many simulations is done per second, the number of bits per second. So coming on to this void loop. So this loop reads pin number 2, that is the input, and it shows the output. So digital write 13, high. So that is, if there's any intruder or an object inside the range or the vicinity here, it shows that it's high. If it doesn't detect any object, it shows low. And then we have a delay of 10 seconds here. So that's what you see here. When I just click for a second, you see multiple 1 or multiple 0. So that's what we have the delay for. So I hope you understood this. The intruder alarm for this. Now I have a few questions here. So that question tells us how you can advance. So this is a very basic and common, the most simplest of intruder alarms created. But what if you can create multiple? What if you can use multiple sensors, different sensors? So you have the IR sensor, ultrasonic sensor, temperature sensor, etc. Many more. Different systems using problem statement. I'm going to show you guys. So the first statement is, what if you can use a temperature sensor to create a fire alarm? You can just add the temperature sensor to detect the smoke, to detect the rise in temperature, and it helps you with identification if a fire is there or not. And the next thing is, what if you can use an ultrasonic sensor to detect the sound movement? It is the smallest of noise. So yeah, that's it. So I hope you understood what we're and I hope you can take some bit of knowledge from this, and I hope you can also start creating your own projects using this. Thank you.
Thank you, Madhumita, for sharing your knowledge. Now I call upon Ms. Ivashri to take over the session.
Thank you, Sweetie. Good evening, everyone. This is Ivashri here to take over the session from now. Thank you, speakers. Let us move on to question and answer session. Now, these questions are for Ms. Madhumita. First question for you is, why are you using PIR sensor? Can we use other sensors too?
Yes, instead of using the PIR sensor, you can use the IR sensor to write in this place. But like I said before, the IR sensor can only detect the object present in front. The PIR sensor can also detect the motion of the object. So that's one advantage of using the PIR sensor.
Okay, and the second question for you is, what is the difference between analog and digital pins?
So the analog pins read multiple values, like it reads values from 1.2, 1.32, but the digital pin reads only the values 1 and 0. So that's why we're using digital pins here. We need only two outputs, that is if it either works or doesn't work. So that's why we're using only the digital pins.
Okay, and the third question is, can we connect the resistor to any other pins too? Will it work then?
Yes, we can connect the resistor to any input pin or the output pin from the digital pin section. So they'll definitely work.
Okay, thank you, Madhumita. And the next questions are for Ms. Reshma. First question for you is, why do we use resistors in the circuit?
Now, the reason why we use resistors in the circuit, that it's because the LED can only like withstand certain values of current. That is, like, it can only withstand current up till like 0.20 amperes. And in order to like to regulate the current which passes through, and we don't want the entire current to pass through. We need to regulate it and make sure that the LED doesn't get short circuited or get combusted. So that's where resistors come into play. They regulate the amount of current which passes through and make sure that the circuit works properly.
Okay, and the second question is, do LDRs have both positive and negative terminals?
Actually, it doesn't though, because LDR is nothing but just a resistor ultimately, and like every other resistor does, it doesn't really have like a positive or negative terminal. So yeah, LDR doesn't really have polarity.
Okay, thank you, Reshma.
Thank
Thank you, Madhumita and Reshma, for clarifying the doubts. Finally, on behalf of St. Joseph's Robo Club, St. Joseph Institute of Technology, once again, I would like to thank Ms. Madhumita and Ms. Reshma for this workshop. My sincere gratitude to the Almighty for always showering us with this immense blessing. My heartfelt thanks to our beloved chairman, Dr. B. Babu Manoharan sir, Managing Director, Mrs. S. Jesipriya ma'am, and our Director, Mr. B. Sasishekhar sir, for their guidance in the conduction of this workshop. Also, I would like to express my gratitude to our principal, Dr. P. Ravichandran sir, for his support in conducting this workshop, and our department heads, Dr. C. Jnanakausalya ma'am, Student and Staff Affairs, and Dr. C. Rohini ma'am, Lab Affairs, for their words of encouragement and guidance. I would also like to express my gratitude to the head of the departments and lab HODs of CSE, IT, EEE, Civil, Mechanical departments, and Department of Science for gracing today's occasion. I would like to take this time to sincerely thank our department staff and the organizing team for arranging this workshop successfully. Last but not the least, my sincere thanks to all the participants for your active participation and support. We truly hope that you took away something of value through this. Kindly fill the feedback form. This workshop series will be continued tomorrow by Ms. Jamuna on Password Please. We expect the same participation from your side. Thank you.